Well, we set stuff up yesterday. You guys remember what the reciprocal of sine was yesterday?
Yes.
Cosecant. What was the reciprocal of cosine? Secant. And then the one that was easy is the reciprocal of tangent is? Yeah, so we worked on that yesterday. And then we talked about example 4 when we finished up yesterday. We said, hey, by the way, when you solve a right triangle, how many angles are you trying to find? 3 of them. And how many sides are you trying to find?
30.
So how many parts are there really involved in solving a right triangle? 6. 3 sides, 3 angles, okay? So what we want to do is take what we learned yesterday and apply it to some problems here. The first one here, we're going to change some numbers in this diagram. I know this diagram doesn't show up the best on your notes, but I think we'll be in good shape. It says you're hiking near a canyon similar to the one illustrated over here, okay? It says, while standing at point A, you measure the angle of how many degrees?
90.
Okay, so at angle A, this angle is really how many degrees right here?
90.
90 degrees. So I need to get my tools. Hang on one second. All right, so my tools right here. Let's put this in that actually. By the way, any of you guys been to the Grand Canyon?
We're going there this summer.
Are you going there this summer? Very cool. Okay. I've been to Arizona. I've never been to the Grand Canyon. I've been to Arizona once. We went to a place called Sedona. I looked at the red rocks there. So
Pardon?
cool. Yes.
And Haven Elder for the office. She'll be leaving.
Okay.
Yep.
Hey, man, I got a couple of copies here for you. So here's the deal. In Sedona, Arizona, there's actually one of the red rocks. That's one of the ones that's out there. There's one that looks like Snoopy laying on his back. Have you heard about this before?
No.
And I was like, this is a myth. But sure as you know what, it's true. That's what they're going to work on today, okay? All right, but sure as it is. It's like we were just driving around out there where we were supposed to drive around, and all of a sudden there it was. It's like, whoa, it really does look like Snoopy. Look it up on Google if you want sometime. Sedona, Arizona, Snoopy Red Rock or something like that. And it's kind of cool when you get time here, okay? So we know that this is 90 degrees down here at angle A. Is that true?
Yep.
Okay. And then it says you measure the angle of 90 degrees between B and C. Okay, as shown in the diagram. You walk to B and measure an angle of how many degrees? Okay, we're going to change this 76 to how many degrees?
63.
Okay, we're going to call this 63 degrees. Okay,
Well, there it is. Yeah.
did you see it?
Yeah.
It looks like Snoopy, doesn't it?
Yeah.
Isn't that cool? Like he's laying on his back. It's weird. In person, it looks a lot more defined than it does in pictures. Yep. And then you put the arc around it. It's crazy. Okay. It says you walk to B and measure an angle of 63 degrees between A and C. It says the distance between A and B is what, kids?
5 miles.
Okay, so we need to change 2 miles to what here?
5.
Okay, so we're on this side right here. We were at A. We measured a 90-degree angle looking straight at C. Okay? We walked how many miles this way, kids?
5.
And then we looked back at point C up here and we said, ooh, that angle formed with this and that line. The line we walked to C is how many degrees?
63.
The question says, how wide is the canyon between which 2 points?
A.
So we're looking for this distance right up here, X, aren't we? Okay, so kids, really what acute angle are you going to reference from the way we redrew our diagram? So that is how many degrees, kids?
60.
Relative to our reference angle of 63 degrees, what is 5 miles in? A leg or hypotenuse? Furthermore, what kind of a leg? This is my adjacent leg. Yep, you're ahead of me already. The length we're trying to find X, the distance from A to B, we're using this indirect measurement. We didn't even cross this canyon, but we're going to figure out how far it is just by angles and how far we walked over here, right? This here would be what kind of a leg relative to our 63-degree reference angle?
Opposite.
Okay, so which function is going to involve the opposite leg and adjacent leg of the 3 easy ones that we know? Tangent again. Okay, so help me set this up, kids. We're going to go tangent of how many degrees? Okay, by definition, tangent is defined as what over what? Opposite leg over the... Okay, so what over what in terms of our measurements or our variables? X over Okay, so this is where we get into our calculator. Do you guys remember how many places I wanted you to go on trig functions yesterday?
4.
And always put that decimal over.
1.
All right, so talk to me. Tangent 63, friends.
1.9626.
All over 1. That's going to equal x over y here, kids. All right, so you run with the cross multiplication. We'll do our distances to the nearest 10. I don't know what big ideas if they're going to have you go nearest 10 or 100. I have no idea how that's going to look. But just be careful when you're reading your problems for a homework today. What do you guys get for the distance across that canyon?
9.8.
9.8. We all agree 9.8?
Yeah.
I like 9.8 miles. I think that's right. What did you have, 1.9?
Yeah,
Maybe about 9.5 and 0.3. Yeah, 9.8 is good. Right? I like it. So kids, did we even do anything to get from point A to point C here? Well, we did some work here. He said, I can look right here and I can look this way and say, okay, I'm looking this way. I know it's a certain distance across the canyon. I can walk a line that's 90 degrees from my line of sight here, can't I? And we walked how many miles? And when I got 5 miles away, I was at point B, and then I looked back at point C here and said, okay, the angle with the line I just walked and the line of sight is now 63 degrees. This is called using what type of measurement, kids?
Indirect.
It's an indirect measurement because, did we ever measure this distance A to B?
No.
Indirect means you need to calculate that measure. All right? Indirect means you calculated that measure. You didn't actually measure it, you calculated it. Okay? So 9.8 miles, good. Okay? Does everybody understand why we use tangent right here?
Okay, so why could be as parallel? So, like, how do you know the cotangent? Like,
Okay.
could you use cotangent?
I could have used cotangent.
Okay.
Okay? Here's why I suggest sine, cosine, or tangent. Okay? Because those are the 3 buttons that are in your calculator.
Oh.
Does that make sense?
Yeah, okay,
Okay.
that makes sense.
You okay with that? Okay.
How do you know
Well, you guys got a reference from an acute angle. Okay? So once in this diagram right here, I can't use 90 degrees, that's not acute, right? So we knew this angle was how many degrees? So it's kind of like saying we were at point B, we are standing here. We know that the distance at point B to point A is 5 miles. This becomes like an adjacent leg to that reference angle, doesn't it?
Yeah.
Okay? And then the distance I'm looking for is this distance x right here, which is an opposite leg. So if you think back to this again, I'm choosing tangent because that's the one that involves an opposite leg and adjacent leg. Those are the 2 things that we have relative to your reference angle right here. If I would have known this distance, if I would have been looking for the hypotenuse right here, let's say I didn't want to know this, and I was looking for the hypotenuse here, x, then it would become adjacent leg and hypotenuse. You would have used the cosine now. Okay with that? So you're always labeling stuff relative to your reference angle, or in terms of where you're standing. Okay? Good with that?
Yeah.
All right. Let's try another one. Last page here, kids. Do you guys have what you need right there?
Yeah.
Okay, last page. Ooh, this is a good one. Okay. All right, first of all, elevation. Is that something that's increasing in height or decreasing? Okay, you're going to hear 2 things here in this section. You're going to hear an angle of elevation. You're going to hear an angle of depression. Okay? Angles of elevation and angles of depression are always related to a horizontal line. Okay? This is going to be an angle of what? This would be an angle of, all right. Guys, get that? Okay. Elevation and depression are always relative to a horizontal line. So if somebody was on the floor down there and they had to look me in the eye, is that an angle of elevation or? Okay. If I had to ask you guys all to stand up and look me in the eye, is that an angle of elevation or depression?
The elevation would be taller.
I'm taller than everybody in here, so it would be an angle of elevation, okay? How about me when I look into your eyes? It's an angle of depression. You have to look down at you. Not that I'm looking down upon you, but I just have to because I'm taller. Okay? Ease down. All right. Let's talk about this right here. So, have you guys ever been parasailing before?
No.
I see it a lot. Sometimes when we'll take a trip, we like to go to Orange Beach or Gulf Shores, sometimes I'll see people out there and I'm like, I want to try that.
Yeah, it
And I'm
looks
like,
really fun.
I'm like, looks really fun, but then I kind of chicken out.
You should just do it personally.
I
Yeah.
should just go
Do it
for
for the,
it.
do it for the math example.
My big deal is if I don't come back from this, then I can't have candy bacon and an ice cream sundae at the Sunliner Diner. And that bothers me, okay? I'm like parasailing and dying, or not parasailing and being guaranteed to have a
But if you
brownie
don't
sundae.
parasail, then you'll never know if you that
I
will
know, this is true.
Just do it.
I'm
Do
afraid
it.
of heights, honestly.
You'll regret it if you don't do it.
Maybe I will this summer.
He might regret it if he does do it.
I might
No,
regret it if I
no.
do it too, okay? Especially if somebody's filming it. I don't
Sir, if it
want
goes
to.
badly, he won't regret it.
Alright, so the parasailer is attached to a boat with a rope. How long is the rope, kids?
80 feet.
Okay, the angle of, here it is right here, kids. The angle of what?
Elevation.
Okay, guys, you gotta understand, if I ever use angle of elevation or angle of depression, it's always relative to what kind of a line?
Horizontal.
Okay, so there'll always be some kind of horizontal, so we're assuming maybe the ocean or whatever body of water we're on is flat right here, okay? We'll say maybe the boat is right here, don't make fun of my boat.
Oh, wow.
Better than my boat.
Are you doing the sail on it?
No sails today, it's a motorboat.
You've got to.
I would make it a sailboat.
Angle of elevation here, kids, what's the angle of elevation for that chord?
31.
31 degrees. Now, the angle that we're talking about is always made with the horizontal part. Okay, so we're going to call this 31 degrees. Okay? Kids, what's true about the length of the rope?
80 feet.
So if this is 80 feet, wouldn't that be from the boat to where I am up here yelling, oh my God, get me down?
Yeah.
Yeah, I guess it'd be hard to
Okay.
to do that with the sailboat.
Oh, wait. Sailboats?
I really like the.
Can't wait till the all my people do
Okay.
Look at that great drawing.
that.
The angle of elevation from the boat to the parasailer is 31 degrees. Estimate the what, kids? So we're kind of looking at the height right here when it says, how far above the water are we really? And we're assuming what kind of angle when I go straight down to that horizontal.
90.
We'll assume 90 degrees. Kids, do I have enough information? Oh, I forgot to label something. What did I forget to label? The length of the rope. Okay, what line is that? The red line or is that the blue line?
Right, right.
80 feet. Okay. What are we trying to find?
The length right there.
Okay, so kids, first question when you're answering or trying to solve parts of these right triangles, ask yourself, where's my reference angle? What do you want to make your reference angle?
31.
So we're going to reference everything from down here, right?
Yeah.
At this angle? Okay. How is the H related to our reference angle?
It's opposite.
Opposite leg. How is 31 related to your reference
It's the
angle?
hypotenuse.
So which of your three simplest functions, sine, cosine, or tangent, will involve the opposite leg and a hypotenuse? So we're going to set this up as sine of how many degrees, friends?
31.
Sine of 31 degrees. Let's see. Definition of sine, what over what? The opposite leg over the hypotenuse. So in this case, h over 80. All right? You guys start crunching numbers. Sine of 31 to 4 places, please. 5150? So 0.51. 50 all over 1. You guys buying what I'm selling right there?
Yeah.
Cross multiply and divide. How about a height to the nearest tenth, friends? 41.2. Well, this was all measured in feet, wasn't it? Yep. Okay, so 40 feet in the air. What's this ceiling right here? 8 feet? Must be. Maybe it's 9, 8. Gotta be 8. I'm going 8.
Honestly?
I'm standing up.
Gotta be 8.
That's
Because I'm 6'4".
Yeah.
Yeah.
All right, Michael Jordan. Yeah, that's it.
Okay. So that would be like, what, 5 of those? I don't think so. I don't think so. Okay. All right. Kids, as far as notes go, what questions do you have so far?
Not anymore.
Okay. Let me stop this real quickly. I want to know if you guys have any questions on any of the problems on big ideas that maybe you started looking at yesterday. I probably won't pull that in until Thursday morning. Is that going to be fair?
Yes.